The noisy channel coding theorem, proposed by Claude Shannon, is probably one of the most important results of information theory. Now we'll introduce this theorem here. This theorem is related with the channel coding for error detection and correction. The idea is that channel coding allows to have a reliable transmission under an unreliable channel. And to do this, it is necessary to introduce some structured redundancy in the information that is transmitted. Usually, K information symbols are carried by transmitting N symbols. Obviously, N must be greater than K. And in this case, there are a coding rate. The coding rate is the ratio between K and N. And the simplest way to perform this introduction of structured redundancy is to use block codes with a given dictionary. The information is split, the information bits are split in blocks of K bits, and there is a dictionary with the blocks of K bits, this is called the index set, and the blocks of M bits that will carry these K bits of information. These are called the coded words. Here we have an example for a code with K equal to 1 and N equal to 3. Here we have another dictionary for another code with K equal to 2 information bits and N equals 6. The coded words are words of 6 bits. In the transmitter, the information bits are split in blocks of K bits. Each block, according to the dictionary, will be converted in a block of M bits. These blocks of M bits are transmitted in the discrete memoryless channel, and then at the receiver, each block of N bits is converted back to the K information bits. There is an intuitive idea, and the intuitive idea is that the code rate, the ratio between K and N, is maintained, but both K and N are increased, like for instance, in this case, instead of having 1 and 3, we have 2 and 6. We have the same code rate, but with higher values for K and N. And the intuitive idea is that by increasing K and N, the probability of error will decrease. This intuitive idea is correct, but with a limit. And this limit is channel capacity. In 1948, Claude Shannon presented the noisy channel coding theorem. And in this theorem, Claude Shannon said that first, if the transmission rate, if the coding rate is lower than the channel capacity, then it is possible to obtain a transmission with an arbitrarily low probability of error. By increasing enough N, it is possible to reduce the probability of error as much as necessary. But if the coding rate R is greater than the channel capacity, this is not possible. There is a bound for the probability of error, and it is not possible to reduce arbitrarily the probability of error. And Shannon also stated that there are codes that allow to reach the channel capacity. Therefore, the channel capacity is the maximum amount of information that can be transmitted in a channel with reliability. And taking into account that distortion happens during the transmission, there is a potential loss of information. However, we can define a reliable transmission. The ideal definition should be a transmission without loss of information, zero probability of error. But in practice, the definition of a reliable transmission is a transmission where we are able of reducing the probability of error as much as necessary. The probability of error can be arbitrarily low. And the channel coding concept is the mechanism that allows a reliable transmission. The introduction of a structured redundancy in the transmitted symbols allows a reliable transmission, allows a transmission with an arbitrarily low probability of error. And the channel capacity can then be defined as the limit in the number of extended symbols, number of symbols of length n, that can be transmitted with an arbitrarily low overlapping in their outputs. And this when the number of uses of the channel n tends to infinity. This is basically the definition of channel capacity. And channel capacity has been analyzed and has been obtained for the digital channels, for the DMCs, and for the Gaussian channels. We will present these capacities in further videos.